Hey everyone, I wanted to spend a little bit of time today discussing a growing trend that I've noticed in the industry and that I haven't seen it covered in a comprehensive way anywhere. And I think that we should have a conversation about it as a community. So I'll bring up the topic now and then very keen to hear your feedback. The best way to describe it that I can think of at the moment, and I'm sure it'll evolve, but the best way I can think of at the moment is the rise of engineers in the data analytics space. And I think this started about 7 years ago with the first one was the data engineer. And then over time, we've also as an industry, as we've been maturing and the demands from business have been increasing on our industry, we've also developed more specialized roles that are the analytics engineer, the machine learning engineer, and the artificial intelligence or AI engineer. And all those, in all those four, so including the data engineer, in all those four, we are heavily leveraging from our brothers and sisters in the IT side, where initially with the data engineers, it was us, borrowing or learning from the capabilities of software engineering, and then from then on, we also were leveraging capabilities from other roles in the IT side, like cloud engineering, DevOps engineering, and site reliability engineers. And that's because the way that I see it, and as I mentioned, keen to get your thoughts, as an industry, as we've been maturing and getting additional demands from business for the products and services that we're building internally, and that could be a dashboard, or it could be an API making a prediction. It can be even some data, like making data accessible. If we think of those as products and services that we, as an industry, are providing internally or externally to the organization, those have become more and more integral to the organization, more and more integral to the way that people work, to the processes, the workflows, the decisions that we're hoping, and that as an industry for a long time we've been hoping to help organizations become more data driven and get more value from the data. As we've been doing that, the stakeholders, the customers, the business has started to expect greater reliability and availability on our systems, and that's where we've been borrowing from software engineering, and that's where I see the term engineer come in and play a big role. So essentially, we're taking the disciplines and the titles and the terminology of the data analytics space, and we're adding this engineer suffix or surname to the titles. As I was saying before, with the data engineer, analytics engineer, AI engineer, ML engineer, we're having engineer in there, and essentially what is increasingly expected of the engineer is to build systems that are reliable. So data processing pipelines that are reliable, build dashboards that are reliable, build machine learning and AI systems that are reliable. Also, these systems across the board, they need to be accessible. They need to have good performance. They need to be monitored appropriately. That if and when anything goes wrong, you need to be able to dive quickly into the key component that had the issue. Being able to check what was wrong and being able to remediate that quickly. is the expectation, because more and more people are depending on these systems in an ever increasing way. So being able to create our platforms and our pipelines in a way that we can have great visibility across the board, being able to orchestrate these complex, very complex and ever increasing data pipelines. It's critical. It's critical, and it's something that we've been doing as an industry. And as I mentioned, I haven't found a description, a succinct description, a title, I haven't found it yet, and so I'm sure it'll come. But essentially, it's almost like we can have data engineering as the overall banner, and have obviously data engineers in there, but analytics engineers, AI engineers, machine learning engineers. We're wanting to optimize the delivery of large and complex data systems. We're wanting to identify opportunities to improve our data processing pipelines, our infrastructure. There's a big piece on infrastructure, and being able to, stand the things up on the cloud, being able to take them down. From a cloud engineer, or some of the things that we've learned from cloud engineering is things like treat your infrastructure as cattle, not as pets. I don't know if you've heard that before. When I first heard it, I loved it. And the difference there is that and it can be a bit morbid in terms of an analogy, but it's a good one. With a pet, you have very few, and you want them to live as long as possible, and you want to spend the most amount of time with them as you can. With cattle, they're more for an outcome where they have a set life, and they're gonna go to an end of life that will likely be either them being slaughtered and then being sold. And it's a much more it's a process-oriented, structured methodology that is followed. That's what we want with our cloud infrastructure. Something that ideally is infrastructure as code. So very sort of Terraform heavy. Something that we can stand up, use, break down, delete if we need to, stand up multiple different copies. Being able to do that in a repeatable and reliable way, that's something that is critical in this engineer space, and for us to do that across the areas that I was mentioning before. So the data processing pipelines, the visualizations and dashboards, and also the AI and machine learning systems. We want to have them running on the cloud, being able to use the best of breed of the public clouds as much as possible, and I should add, where it makes sense, and in other cases it makes sense to have to double down on one particular cloud platform, and that's definitely the case for I would say for smaller organizations, for startups. And because then as complexity grows, as our organizations grow, it might make sense to go from a single cloud to a multi-cloud, to optimize for cost, or to have disaster recovery, things like that. But there's definitely an additional cost from a technology skill set perspective, and from a talent perspective. There's a lot more cross-skilling required to go multi-cloud. But some instances of having high availability and high reliability of our systems will create that need, and part of it will be driven by regulators. So there's definitely a big push there, where we as an industry will continue to learn from cloud engineers in that aspect. And the other part that we've been learning a lot from is the DevOps movement, particularly with the continuous deployment and continuous integration that are key components to DevOps, that before, from an IT perspective, from a software engineering perspective, before DevOps, the software releases were done very few times in a year, say, and then the push for DevOps was to be able to create more releases more often and do that in a secure and scalable way. And DevOps allows us to do that by having small pieces of code that are integrated and deployed into our systems with a bunch of testing in there to be able to make sure that what we're releasing to our customers will work. And then that's how on the cloud we were able to get software that was and continues to be always evolving and always improving. That's the type of methodology and mindset that we want with our data processing pipeline and our analytical products. So additionally, in the DevOps world, there's the monitoring and the performance. There's the scale of the systems. All these things we are learning. So now we can, both create internally APIs that can do single row predictions in a kind of like in a streaming manner, do predictions based on machine learning models by having the machine learning model behind an API, and being able to offer that as a service internally in our organizations or externally to our clients. And through the podcast, we've had really good examples of people telling us about how they got to that level of maturity in their machine learning engineering and in their AI engineering, and it really liberates both the technology, the power of it, but also the resources, because people are able to work on things that are at an industrial strength level. So with all that, I think this rise of engineers in the data analytics space, it's a growing trend. I think is a key trend where, as an industry, we're maturing, we're further specializing, we're reacting to the demands of business, and we're seizing the opportunity to continually create more value in our organizations. And as you know, like, I love all those things, and I think that they're all excellent. And I think that we should have a conversation about it, a conversation about how are we going about this? Are we doing it consistently? Are there things that we can learn from each other? Can we look at team roles or team structures? Can we look at tools? So obviously the modern data stack is a key set of tools for us to use in this engineering world that we live on now in the data analytics space. So are there ways that we can share amongst the community better ways to either implement or use the modern data stack? What about the reliability, the monitoring, or the leadership, the management of these teams, the dealing with the business side? We should discuss. We should talk about it as a community. We should learn from each other and make sure that we are continually growing in this space. So for that, Data Futurology is putting together an event that we're calling Data Engineering Summit, and this is to encompass all of the four types of engineers in the data analytics space that I was mentioning before. This is, at the moment, it's going to take place in Sydney on the 10th of May. And I'm very keen for you guys to come along. We're going to get great speakers to share their perspectives on some of the things that I've mentioned today. But between now and then, and as soon as possible, I'm keen to get your feedback to see what else we should include, what topics we should cover, what angles we should cover with those topics. And then we can make the best event that we can for the community. As you know, we're always trying to give you as much value as we can, and we want to provide to you the sessions that you can walk away from and immediately be able to add more value in your organizations. So hopefully we've been doing that. We're keen to do this with the engineering space in data analytics, If there's a better term for it, please let me know. Anything we should cover, let me know. And I'm so keen to see you there on May 10th in Sydney for Data Engineering Summit. Thanks so much, everyone. I'll see you there. Thanks for watching this video all the way to the end. I hope that you got a lot out of this discussion. And if you're watching on YouTube, please like and subscribe to the channel so more people can find out about the challenges that leaders have in the analytics and AI space. And that's what we're trying to share in Data Futurology. So please like and subscribe. And if you enjoyed today's episode, please tell your friends. Thank you so much.